Monte Carlo methods often rely on Markov chains, a mathematical framework that models random processes where the future depends only on the present state, not the past. This principle makes them essential for many simulations. 1. What is a Markov chain? A Markov chain is a sequence of random events where each step depends only on the previous one. Key properties. Memoryless. The next state depends only on the current state, not past states. Transition probabilities. The system moves between states based on fixed probabilities. Example. Imagine predicting the weather. If today is sunny, the chance of tomorrow being rainy or cloudy depends only on today's weather, not on what happened last week. 2. Monte Carlo methods and Markov chains. Markov chains are used in Monte Carlo methods to sample from complex probability distributions. This is known as Markov chain Monte Carlo, MCMC. Some distributions are too complex to sample from directly. Markov chains help explore these distributions step by step. They allow simulations in high-dimensional spaces like Bayesian statistics and physics. Key techniques in MCMC. A Metropolis-Hastings algorithm generates a sequence of samples by proposing a move and deciding whether to accept it based on probabilities. Helps estimate unknown distributions efficiently. B. Gibbs. Special case of MCMC where variables are sampled one at a time while keeping others fixed. Useful in Bayesian inference and machine learning. 4. Applications of Markov chain Monte Carlo. Finance, risk modeling and asset pricing. Physics, simulating molecular behavior. Machine learning, Bayesian networks, and deep learning. Why is MC powerful? Works for complex problems where direct sampling is impossible. Adapts to high-dimensional spaces efficiently. Provides accurate estimates with fewer computations. Markov chains and Monte Carlo methods together enable powerful simulations and predictive modeling across many fields.